Well, let's talk about your test. Specifically, let's talk about the written section. There's probably going to be 4 written questions, maybe 5, and I'll tell you one of them right now. One of them is going to be very, very similar to from quiz 1 when we're in orbit. I'm going to either give you orbital speed, orbital radius, orbital altitude, or orbital period. And I'll probably ask you to find 2, maybe 3 other things, because if you know 1, you know all 4. So you'll start out with gravity is what's pulling me in a circle. There's going to be a question probably like that. I think that you can expect there's going to be some kind of a question involving work, like number 3, or, wait a minute, now let's go back to today's quiz, work like number 1. So what are they asking me to find? How much work? Work is going to be the change in potential plus the change in kinetic. If it was just lifting this into outer space but not putting it in a stable orbit, if I was just lifting it, I could do that. Are we in a stable orbit? Then I have to have kinetic energy. Oh, and moon. I'll make sure I use the correct numbers for the moon. I mean, it would be silly to do all my physics with the wrong planet. That would just be silly. Who would ever do something like that? It's all on my data sheet after all. I find this question is big enough that I tend to do it in chunks. I'm going to find the change in potential energy, which is going to be negative big G, big M, little m over R final minus negative big G, big M, little m over R initial. The change in potential energy is going to be negative big G. Mass of the moon, I got to look that one up. It starts with a 7. 7.35 times 10 to the 22. I've never bothered memorizing these because what if I foolishly memorized them wrong? Well, it's on my formula sheet, so I can just use my formula sheet, and that way I don't make a silly mistake or enter the wrong data or something like that. Right? Yeah, I mean, right. Does little m cancel here? Not this time. So 1600. R final. Ooh. This is a height. So I'm going to take that distance and I'm going to have to add the radius of the moon, which is 1.74 times 10 to the 6th. If it had said orbital radius, I wouldn't have had to add the 1.74 times 10 to the 6th. But because this did that, altitude, I'll have to do that. Then I have a plus, same thing times same thing times same thing, all over 1.74 times 10 to the 6th. Oh, now we start doing a fair bit of typing. It's going to be negative 6.67 times 10 to the negative 11 times 7.35 times 10 to the 22 times 1600 divided by bracket 2 times 10 to the 6th plus 1.74 times 10 to the 6th. For the first term, did you get negative 20? I'm going to go negative 2.0973. There's a good spot with a 0 to round off to. Times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 2.0973 times 10 to the 9th. The Earth, when we were doing these questions for the Earth, Taryn, it was often in the 10 to the 10th or 10 to the 11th range. Does 10 to the 9th worry me? Would the moon require more energy or less energy to launch a rocket into orbit from the moon? Does the moon have bigger gravity or weaker gravity than the Earth? You know what? 10 to the 9th or 10 to the 8th, I think I'm good with that. Okay. Then I have a plus sign. Oh, now I can just backspace and edit. In fact, I think all I need to do is delete the negative and the 2 times 10 to the 6th. 4.508 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. 4.508 times 10 to the 9th. Take away 2.0973 times 10 to the 9th, or plus negative, but that's the same as take away. And okay, the change in potential, I get 2.4107. times 10 to the ninth. 2.4107 times 10 to the ninth joules. I'll put a box around that so I can find it easy later. Am I done? No. This would be how much work to lift something up there, but not to keep it up there. This would be how much energy you need to lift it up there, how much rocket fuel. If we knew how many joules per liter, we could figure out the rocket fuel pretty accurately. I need to find the change in kinetic. Sorry, change in kinetic is going to be KE final minus KE initial. Final minus initial. We said that we're launching from the North Pole, even on the moon. I know the moon doesn't have a North Pole per se. There's no Santa's workshop. Superman might have a Fortress of Solitude on the moon. Who knows? But we're launching from there. So it's just going to be a half little m v squared. 0.5 times 1600 times, oh, they gave me v, 1,145 squared. That's what 1.145 times 10 to the 3 is. Again, I'm probably expecting a 10 to the 8th or 10 to the 9th range because the moon, less gravity. Let's go see. 0.5 times 1600 times 1145 squared. I get 1.0488 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. That seems ballpark, right? 1.0488. Times 10 to the 9th joules. Am I done? No. The work is add those two together. Wow. It's going to be 2.4107 times 10 to the 9th plus 1.0488 times 10 to the 9th. 2.4107 times 10 to the 9th, plus I can just go answer button. Alrighty, 3.46 times 10 to the 9th. If you got that right, how many marks did I make this worth? 7, good, that's what I would do on a test. This is a long question. If you got it right, 7 out of 7. Otherwise, how would I give out part marks? I would give a half mark out if I saw that you would recognize we're going to use the work energy theorem. I would give a half mark if I saw that. I would give a half mark if I saw that you would realize we needed to add the radius to the altitude. And then I would give you half mark for that. You know what? I'd probably give you 1 whole mark for that. And in fact, I would probably give you 1 whole mark just for realizing that it was the work energy theorem. So what's that? 1, 2, 3 would give you 1 mark if I saw that, 1 mark for the answer, 4, 5, 1 mark for adding them together, 6, and then 1 mark for getting it correct, 7, something like that. Whew. Oh. How much work. Too much work. Are we in a stable orbit? So this is really similar to the question that we just did. Why is this 1 step tougher? So was the last one. Why is this 1 step tougher than the last one? Yeah. I'm going to have to figure out orbital speed by going gravity is what's pulling me in a circle. This is about as much as I can throw at you. I'm giving it to you on the quiz. I'm not going to give you one like this on the test. I will give you one like this on the test where I give you the orbital speed, but I'm just not going to combine them. I'll do that as a separate question. Gravity is what's pulling me in a circle. Alrighty. Wow. Well, work is the change in potential plus the change in kinetic. This is going to be a lot of writing. The change in potential is going to be negative big G, big M, little m over R final minus negative big G, big M, little m over R initial. The change in potential is going to be negative big G mass Earth. I'm not even going to write that out. I'm feeling lazy. Times 3200 divided by that 8.3 times 10 to the 7th. Do I need to add the radius of the Earth to that or not? How do you know? Oh, orbital radius. So they've already done that for me. 8.3 times 10 to the 7th. And then I'm going to have, almost forgot, there's a minus minus there, which is a plus. Plus, same thing, times same thing, times same thing, all over. What's the radius of the Earth, Mud? Good. Alrighty. Now is where I'm going to be very meticulous and careful because I'm going to be reusing this calculation a few times. Negative 6.67. No, already made a typo. Negative 6.67 times 10 to the negative 11 times 5.98 times 10 to the 24th times 3200 divided by 8.30 times 10 to the 7th. Did I make a typo at all? Looks good. For the first term, did you get negative 1.5378 times 10 to the 10th? Negative 1.5378 times 10 to the 10th plus, and then all I need to do is backspace and edit and change this to 6.38 times 10 to the 6th. That's why I put that extra 0 there so I could just type over it. I forgot the negative, Mr. Dewick. Do that again. Positive 2.0006 times 10 to the 11th. Alrighty, so the change in potential is this number, take away 1.5378 times 10 to the 10th. And I get 1.8468 times 10 to the 11th. 1.8468 times 10 to the 11th joules. Put a box around it. We're not done. I got some room. Yeesh. I now want to find the change in kinetic, which is going to be kinetic energy final minus kinetic energy initial. No, we're launching from the North Pole. Problem. The change in kinetic energy, that's going to be equal to a half m v final squared. I don't know v final squared, but I can say gravity is what's pulling me in a circle. I can say big G, big M, little m over r squared equals m, v, whoop, that's terrible, Mr. Duke, v squared over r, because I'm trying to find v. M cancels, one of the r cancels, and I was going to take the square root, but then I said, wait a minute, there's a v squared here. Why don't I just stick this in for that? I'll get the change in kinetic energy is equal to 0.5. What was little m? 3200 times big G, mass of the Earth, all divided by 8.3 times 10 to the 7th. It's going to be 0.5 times 3200 times 6.67 times 10 to the negative 11 times 5.98 times 10 to the 24th divided by 8.3, scientific notation button, 7. Look for typos, Mr. Dewick. That looks good, that looks good, that looks good, that looks good. And I get a change in kinetic energy of 7.688, no, 7.6890. 7.6890 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. Final answer. It's going to be 1.8468 times 10 to the 11th plus 7.6890 times 10 to the 9th. Is that right, folks? Hopefully, we'll find out. You get 1.92 times 10 to the 11th? Good. Taryn, what required more fuel? Keeping this object in orbit or getting it to the correct height? What required more fuel? The change in potential or the change in kinetic? Way more. Yeah, it's way more energy. Like, the further out you go, the slower you need to be traveling, and so that saves kinetic energy, but you're not making up for it by saving the potential energy. Otherwise, we would just put all of our satellites way out there because it would be more economical. It's not, sadly. 7 marks if you got that. Otherwise, how would I do a mark breakdown? That's a good question. I would probably go something like this. 1 mark for that. I would probably go 1 mark if I saw that, 1 mark for the answer. In fact, probably what I would do is I would give you a half mark if I saw that number and a half mark if I saw that number. So you would get 3 marks for finding the change in potential. You would get 1 mark if somewhere I saw gravity is what's pulling me in a circle. I would give you 1 mark for finding the writing the change in potential. That's 5 marks. I would give you 1 mark for that. That's 6, and then 1 mark for adding them together. That's 7. I think that's right. Something like that. It's a lot of work. Pun both intended but not. It's a lot of work. Number 3. Planet Duick has a mass of pi and a radius of E. That's my kind of planet. Pi is 3.14159. E is 2.7182. Okay. So anyways, Planet Duick has a mass of 3.14 times 10 to the 30th and a radius of 2.72. What's its escape velocity? So there will be an escape velocity on your test. I don't like the term escape velocity. It is a scalar. What should it be called? Not escape velocity. It should be called escape. And the reason I wish they called it that is that would nudge you towards a scalar approach. We're not going to solve this using work because it didn't say how much work. We're not going to use this using solve this using gravity. That's pulling me in a circle. We're not in orbit. We're leaving orbit. What's our approach for finding escape velocity? Conservation of energy. Kinetic. Oh, let's change colors, Mr. Duke. Kinetic initial plus potential initial equals kinetic final plus potential final. Here's Brea where it gets a little bit weird. We want to do this so perfectly that we run out of motion right when we escape the planet. And for us to escape the planet, we have to have no gravity. And if there's no gravity, how much potential energy do we have? We're out at the edge of the universe. So you have this weird situation where you end up with a half m v initial squared plus negative big G big M little m over R initial equals nothing. But actually, no, that works well because now I can just plus this over to this side. I'll get a half little m v initial squared equals positive big G big M little m over R initial. Conveniently, it doesn't matter how big the satellite is. Oh, that's good because I didn't give you the mass of the satellite. I just said what's the escape velocity from the planet's surface. And I guess we're going to end up with, yeah, I've seen this before. Escape speed is going to be 2 big G big M over R. Oh, square root, Mr. Duke. It would be foolish to forget the square root. Okay. It's going to be the square root of 2 times 3.14 times 10 to the 30th. Big planet. Of course it is. It's Planet Duick. 2.72 times 10 to the 7th. All over. No. That's wrong, Mr. Duick. What am I typing here? I'm putting stuff in all weird. Big G, Mr. Duick. 6.67 times 10 to the negative 11. Where was my brain? That's almost as silly as getting the radius of the Earth wrong or something like that when it's on my sheet. So I guess I shouldn't talk anymore. Is that right, Mud? Yeah. He got the radius of the Earth wrong. I was wondering why he kept getting the wrong answer. He just memorized it wrong. I'm really close, Mr. Dewitt, but I'm just off by a tiny bit. Hey, you were at least close. I was like putting stuff in all over the place here. Alrighty. This is a bigger planet than Earth, so I'm going to guess. I just remember escape velocity for the Earth. I think it was 11,000 meters per second. Probably going to be bigger. Just a guess. That looks okay. Don't forget to square root, otherwise you'll need to go faster than light. Do you get 3.92 times 10 to the 1, 2, 3, 4, 5, 6? Meters per second. If you got that, what did I make this worth? 7 marks. I would give you 7 out of 7. Otherwise, I would probably go something like this. 1 mark for using conservation of energy. I would give you 1 mark for realizing it equals 0. 1 mark if I saw that. 1 mark for that. 1 mark for getting the escape velocity equation. 1 mark for the numbers. And 1 mark for the answer. Yes? If you've memorized the equation, I'm good with that. It's just I tend not to memorize stuff. Ooh, asteroid impact. Let's destroy the Earth. How fast will it be traveling? Oh, am I going to start out by going work equals change in plus change in? How do you know? Because this question did not ask how much. Okay. Can I say gravity is what's pulling me in a circle? Is that how? Because that lets me find a speed, doesn't it? We're not in a stable orbit. So that's a common mistake kids make. Oh, speed. Gravity is pulling me in a circle. So what are my options? Conservation of energy. How fast will it be traveling? Okay. Are any of these 0? Is any of the speeds 0? No. Is potential energy 0? Yeah, on the no, not on the surface of the Earth. Cosmically, where is potential energy 0? Nothing cancels? Jeez, Dewitt. A half m v initial squared plus negative big G big M little m over r initial equals a half m v final squared plus negative big G big M little m all over r final. What was that? Oh, at least something does. Okay. What am I trying to find? I guess I'm trying to find this. I would not try and get this by itself. What I would do instead is I would move this term to that side. So now it's going to be 0.5 v initial squared plus negative big G mass Earth. Oh, one little m didn't cancel there. Let's try that. Sorry. Did I accidentally erase it, or maybe I missed it somehow? I have to do that in red, otherwise it's going to annoy me. There we go. Tells you how my brain works. Over R initial plus big G, big M over R final. That equals 0.5 V final squared. So 0.5 VF squared is going to be 0.5 VI. 1.37 times 10 to the 4th. Don't forget the squared. Take away big G, mass Earth, all over R initial. Is that 2.2 times 10 to the 7th a radius, or do I need to add the radius of the Earth to it? Oh, that's nice. What was it? 2.2 times 10 to the 7th? Plus big G, mass of the Earth, all over 6.38 times 10 to the 6th. Okay. 0.5 VF squared. By the way, what if they wanted me to get one of the R's by itself? In other words, they wanted me to, they wouldn't ask R final because that's the radius of the Earth. What if they said, here's how fast it hit the Earth, how far out did it start? I would again do something similar. I would get this term by itself, so I would move the 0.5 V squared over, and then once I turned the whole side into a number, only then would I get the R by itself by going stuff moves diagonally. Because up until then, I wouldn't have one fraction equals one fraction. I would have several fractions equal several fractions. And stuff does not move diagonally then. Okay, this is going to be... Clear. 0.5 times 1.37 times 10 to the 4th squared. 9384500. So 9384530. 9384530. And then take away 6.68 times 10 to the negative 11 times 5. I said 6.68, but I wrote it right. I typed it right, yeah? Sorry, I was already on to the 5.98 in my brain. It's really tricky when you're teaching, by the way. I'll pause for a second. So I was typing correctly at least. Scientific notation 24 divided by 2.2 scientific notation 7. I know there's a minus sign in front of it. I didn't put the negative here. I'll just write the minus sign. Minus 1.813 times 10 to the 1, 2, 3, 4, 5, 6, 7. 1.81, was it 3? 3 times 10 to the 7th. And then there's going to be a plus sign, and I can just backspace and add it and go with 6.38 times 10 to the 6th. And I get 6.252 times 10 to the 1, 2, 3, 4, 5, 6, 7. 6.252 times 10 to the 7th. 6.252 times 10 to the 7th. And now I'm going to add all these together. So I have 93845 minus 1.813 scientific notation button 7 plus answer button. I get 0.5 V final squared equals 1.38 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. 8? 1, 2, 3, 4, 5, 6, 7, 8. Okay. 1.38 times 10 to the 8th. I didn't write all the sig figs because I'm storing it on my calculator. Final step, either times by 2 or divide by 0.5 square root. I'll go times by 2, answer, square root, answer. You get 16,627? So 16,600. If you got that, 7 out of 7. Otherwise, I would probably go something like this. I would give you 1 mark if I saw conservation of energy, GG. 1 mark if you wrote those out. I would probably give you 1 mark for that, 1 mark for that, 1 mark for that. That's 5 marks. I would give you 1 mark if I saw that and 1 mark for the answer. Probably. Something like that. That's a quiz with, that may be the most calculator work you've done on any quiz I've ever given you. Danica, it's rocket science. What were you expecting? It to be easy? Rocket science is literally a euphemism for something that's really tough to master. So, yeah, the universe doesn't give us convenient numbers. Can you give yourself a lovely score, please, out of 28? And can you put that at the top, please?